So we're continuing on with our basic number rules, and now we are going to go into turning fractions into decimals. And so I'm going to start a new column, but you could just continue on with the page, and it's still under the basic number rules. So we're just going to do a bullet point. And in this bullet point, we are going to have turning fractions into decimals. So when you turn fractions into decimals, the first rule is you have to use long division. Long division is crucial because this is how you're going to be able to divide your way to find out what the answer is. Now, we're going to start with a type of fraction, which is terminating decimals. And terminating decimals is when let's draw an arrow here just to define it. It is when a decimal does not repeat. So it terminates, right? Terminate means to stop, like the Terminator, or something like that. So this number will not repeat. And generally, they will be fairly nice numbers, usually numbers divided by 2, divided by 5. Those are pretty good numbers here. So we're going to do an example. And let's say you want to do the number 3 out of 6. Okay, and so you're going to turn it into a decimal. So the first thing that we're going to do is simplify, if possible. So to simplify, if possible, we're going to take a look, and I could see that I could divide. Let me rewrite the 3 out of 6 here so you could always see what the original question was. So I could divide both the top and the bottom by 3. So then I have 3 divided by 3, which is 1. 6 divided by 3, which is 2. Now, we generally know that this most likely would be 50%. But let's do the long division. So the rule that I have for long division is there's this burger chain in the US called In-N-Out. So we're going to call this In and Out. All right. So the thing is, you have to have this little hook here to do long division. And sometimes I would mistaken like which number should go where. Because I would think, oh, because it's in order, I will put the 1 in the front and the 2 inside the bracket. But that's not what you're supposed to do. It's supposed to be in and out. So we have 1, so that's the in, and then 2, out. Now, long division rules, let's do this. So 2 can go into 1 0 times. This means I will have to still be, so I'll have a 0 there. And if I subtract, I'm left with 1. Now, I like doing it properly just so I don't skip steps and make mistakes. Now, I'm going to add a 0, but because there is no other number behind it, I have to add a decimal. And if I add a decimal, I have to add a decimal on top. I'm going to clarify this with red. If you have another color, you could use it too. Remember, this decimal is added on. You got to add that decimal on. Now, can 2 go into 10? Yeah, 2 can go into 10 5 times. So if it goes into, or actually I forgot to put that 0 down there. So 2 times 5, right, is going to be 10, and I could put the 10 there. And 10 minus 10 is going to be 0. I'm done. So my answer here is 0.5. There we go. Put a square around that. That's my answer. All right, and then sometimes you just have to give it a shot with these. Let's say we have a number like 4 over 5, right? And you're like, well, I can't simplify, so simplifying, not possible, right? Actually, let me write example there. So the example of 4 over 5, well, because it can't simplify, let's just jump straight into this. I'm going to have that bracket symbol. And then I have in and out, so 4 and 5 on the outside. 5 can go 0 times, so I put a 0 there because it's 0 times 5 minus, and I have the 4 back down here. Now I have to add a decimal, so I'm going to add a decimal for both numbers, and then I'm going to add a 0. I bring that 0 down. I have 40. Now 5 can go into 40 8 times. Nice. So then 5 times 8 is 40. 40 minus 40 is 0. That's my answer. 0.8. Now, because they're terminating, that means that these numbers can end. But sometimes I don't get terminating, right? So these terminating ones are nice. You kind of finish up the question and you're pretty much done. But what's the opposite of a terminating decimal? It is going to be what we call a repeating decimal. So a repeating decimal is when the long division goes on forever. Some numbers can do this. They can go on forever. Generally, if a fraction has a denominator of like a 3 or a 7, that's usually a sign that it is a repeating decimal. And let me give you an example here. So take a look at this number right here. We're going to have, let's say, the number 1 out of 3. So simplify possible, not possible. All right, so the next step then is I will have to just use the long division. All right, in and out. So I'm going to have the long division symbol. In is 1, 3 is out. 3 can go into 1 0 times. All right, so 0 minus, and I bring the 1 down. I add the decimal point, and now I'm going to add a 0 in that number. So now I have 10. So 3 can go into 10 how many times? Well, not perfectly, but it could go 3 times. That's the closest, because then 3 times 3 is 9. So then you subtract that, and you're left with 1. All right, I got to get another number down. So I'm going to extend my long division there. I'm going to add another 0. I'm going to bring it all the way down right to that 1 over there. So it's going to be 10. Now, 3 can go into 10 how many times? 3 times. And I'm getting 9. I'm left with 1 again. Now, as you can see here, this is repeating. This is going to go on for quite a while, right? If I continue to do this, I could probably go on until the end of the world. And so I could see that I'm really going nowhere with this, right? Oh, I have the 3 there because it's 9. So once you figure out that these numbers are repeating, now you know it's a repeating decimal. So how are you going to label it? You take a look at what number is repeating, and in this case, the repeat actually starts at the first number. So I could just show that it's repeating using a symbol. And so I'm going to write down my answer, which is 0.3, and the 3 keeps repeating. So you have the choice of adding a dot on the top there, or you could add a line. Now this is perfect if 2 numbers repeat over and over again. But this right here is going to be my answer. You could choose one of those. How you write it is up to you. As long as I see the dot or I see the line, I know you know that it's repeating. So let's do one more example here of a potentially repeating number. We're going to do 2 out of 9. Now 2 out of 9 cannot be simplified, so I'm going to continue from here. I'm going to start with the line, and I have in and out. So now I'm going to do 2. So 9 can go into 2 0 times. That means I have 0. I subtract it, and I'm left with 2. Now I'm going to add the decimal 0. I'm going to add a decimal here. So then I bring that 0 down, and I have 20. Now for 20, 9 can go 2 times. If I do 9 times 2, it's going to be 18. Now you may already notice, oh, I got a 2 again. So it probably is repeating, but I'm going to play it safe. I'm going to do it one more time. I'm going to bring this 0, add another 0. I'm going to bring it all the way down. 9 can go into 22 times. So I'm left with 18 again. And I subtract, and I'm left with 2. And you'll see that that's repeating, right? So let's write the answer down. It is going to be 0.2 and a dot, or 0.2 and a line. And that, so I'm going to leave my answer. So this, ladies and gentlemen, is an example of a terminating decimal and a repeating decimal. Now, one last thing just to make it really simple and nice is I'm going to use a different color, but you could just use whatever color. Still stick with the color black or something. I'm going to put a star in that one, so to remind myself, hey, this is important, this is special, it's a terminating decimal. And I'm going to put another one by repeating decimal. Now, the reason why I would do this is just so I could remind myself when I do the assignments that, hey, these are 2 keywords that I'm going to see over and over again. So I recommend that you copy those stars down as well. And that is it for this lesson.